In this video, we're going to talk about mental calculations. So, part of the goal of the elementary system is to help teach students that it's possible to do some math in their head. And a strategy might need to be involved to help do that. So, we're going to kind of go through some of those strategies and discuss how to actually show the work for what's supposed to be able to kind of take place in someone's mind. All right, so the first strategy we're going to talk about is compatible numbers. Compatible numbers kind of pairs numbers that are easy to add, or I should say easier to add, or to, let's say, calculate. It's not necessarily an addition. They're easier to calculate in our head. I would say this is probably the most natural of the techniques that I personally used when I was in school without knowing that this was actually had a name called compatible numbers. All right, so here, let me give an example. Let's say you are asked to add up 50 plus negative 23 plus negative 60. Okay, so first thing I would do if I was doing this in my head is I would pair together numbers that are the easiest to actually combine. Most of the time we try to work from left to right, but we have a math property that says we can switch the order. And in fact, I'm just going to kind of briefly review that property. That's called the commutative property. And that property says that if you're adding, you can swap the order with which you are adding. Same with multiplying. It works for multiplication. It does not work, though, for subtraction or division. Okay, but we are doing some addition. So basically what I'm going to kind of do is swap the order of these two. And instead, I'm going to add the 50 and the negative 60 together because that's easier to do in my head. Now, because the 60 is negative, I'm going to subtract the two numbers. They're opposite signs. And since 60 is the bigger number, that's going to result in a negative answer. And the difference between those numbers is 10. So negative 10. Okay, so now I'll take that negative 10 and I'm going to add it to the negative 23. Since they're both negative, they actually do add together and result in negative 33. And there we go. Okay, so that would be an example of compatible numbers. Let's try a couple more, make sure we get it. Let's say we have 15 plus negative 26 plus 10 plus negative 5. Okay, so I kind of, the 26 is the one that I kind of want to ignore the most. And I'm thinking I'm going to go ahead and combine right off the bat the 15 and the negative 5, mainly because they're going to add up to a very, those two are going to add up to 10. Positive 10, right? Because positive number is bigger, taking subtraction between them. So 15 plus negative 5 comes out to 10. All right, now I'll take that 10 and I'm going to pair it up with this 10 right there, which will give me 20. And then last step, I'll take the 20, oops, and I'm going to add that to the negative 26, which will result in negative 6. All right, so there we go. Pairing up the numbers that are a little bit easier to work with. Okay, let's do something other than addition. Let's do a multiplication. So let's do negative 5 times 18 times negative 2. Okay, so because multiplication is commutative, I can go ahead and pair up negative 5 and the negative 2 and multiply those first, which is much easier. That's going to give me positive 10 because negative times a negative is a positive. And then any number times 10 is super easy. So 18 times positive 10 comes out to 180. So there we go. All right, so that's compatible numbers. The idea is pair up the things that are easier to work with. We really use this technique with addition and multiplication. Those are the two we kind of focus with it. Okay, the next technique we're going to learn is called substitution. The way this works is we will replace a number or numbers with a sum or a product or a quotient or a difference, anything that might make the math easier. Oops. Quotient or difference. And then what we'll use is some of the math techniques, or I'm sorry, math properties, number properties that you've hopefully learned, like the commutative properties. So let me mention those really quick. Let me pause here and just kind of refresh our memory of the two properties we tend to use with this. So there's the associative property. The associative property says that we can change the priority of the math. So normally, when we have something like parentheses, right? When you are looking at something with parentheses, you should start with what's in the parentheses, right? You would add those two numbers first and then do plus C. The associative property says that we can actually switch the order if as long as all of these are added, and instead we could add B and C. So we can literally move parentheses for addition. It also works for multiplication. So if we have a multiplications, we so move which numbers we'd like to multiply first. And then so the distributive property. So the distributive property combines multiplying and either adding or subtracting. So let's say we have A, B plus C. That becomes A times B plus A times C. I could, sorry, I just wrote the A next to the parentheses. You could put a little time symbol there if you want to see that time symbol. But in math, when we put the A next to the parentheses like that, that does mean multiplication. I think most of us probably remember that. So the simplest way of writing this, which if you've taken some sort of algebra, you probably have seen it this way, is without the multiplications. But we know that all of those mean multiplication. Okay, there we go. So we kind of rewrite something so that maybe we can use one of these properties and make our life a little bit easier. These are really best shown by demonstration. So here, let me give you an example. Let's say we have 180 plus negative 37. That might be kind of difficult to do in your head. So it might be wise instead to break up the 37, which is kind of a gross number, and think of it instead as negative 30 plus negative 7. Because that way we can kind of bring the two items with the tens together. I just realized I did it in the wrong color. I have to do it in the right color. All right, sorry. Plus negative 30 plus negative 7. Okay, so basically I'm going to do is use the associative property. And instead, I'm going to combine the 180 and the negative 30 and then deal with the negative 7 when I'm done here. Okay, so the 180 plus negative 30, or basically minus, is just going to be 150. And now this is a lot easier. So if you're subtracting 7, that's going to come out to 143. And that's how you kind of make it a little bit easier. You break up a number into easier pieces so that you can use one of the properties. Let's try another one. Let's try negative 6 times 19. So the 19 is kind of gross. Break it up. Let's think of 19 as 10 plus 9. Now we can do the distributive property here. Sorry, I'm going to squeeze that little multiplication symbol in there. So I'm going to take and instead do negative 60, I'm sorry, negative 6 times 10, which is negative 60, and then do negative 6 times 9. So negative 6 times 10, that's negative 60. And then negative 6 times 9, that's negative 54. Since they're both negative, we add them together, and that's going to give me negative 114. And there we go. All right, let's try another one. Let's try, how about negative 150 divided by, just 6. Divided by, okay. So what we can do is one idea, and this kind of builds on a different property that we're going to see. In fact, actually, I'm going to save it. I'm going to save this for the other property. I just realized that. Let's pause. Okay. Let me see if I can get another example for us. How about substitution, right? Let's try 260 plus negative 49. Okay, so 49 is kind of harder to work with. So I'm going to break it up into negative 40 plus negative 9. And instead, I will combine 260 and negative 40 because that's a lot easier to do. Okay, so 260 and negative 40. Well, that's just 220. And then plus that negative 9, that's going to come out to 211. And there we go. Okay. The next mental calculation we're going to look at, and that was what I was going to kind of use on the problems I was showing, or started to show a second ago, is what's called equal products or equal quotients. Equal products or equal quotients. Okay, so with this technique, what we're doing is we are, well, here, let me say this. Actually, I didn't say anything at all. In my head, I was saying, with equal products, the idea is that we can kind of use the put and take method to help us do the problem. Okay, so we can use, or wow, I'm saying this so badly. The product is unchanged when one of the numbers is divided by a given number and the other number is multiplied by the given number. So we will divide, sorry, the board, the computer gets a little bit fuzzy when I'm low on the board. We will divide one number by a constant, but then multiply the other number by that same constant. Sorry, my computer is just being very funny about my writing, so it was taking a long time to write that, and I apologize. Okay, let me give you an example. And this one is best by example. Let's say I have 12 times negative 54. That's a very difficult thing to try to multiply in my head. All right. But what I could do is break up 12 and think of 12 for a moment as 6 times 2. And that means then what I could do is divide 12 by a 2, but then multiply that 2 by the negative 54. In other words, it's like I'm taking that times 2 and I'm applying it to the other number, because I should be able to do that in my head. So instead of 12, I'm going to have a 6. And then if I want to multiply 54 by 2, then I need to go ahead and just do 2 times 4, which is 8. And then 2 times 5 is 10. And it's negative. So negative 108. Here, let me write that clean. There we go. Now, actually, I could probably do this in my head, because 6 times 8, 48. And then 6 times 1 is just 6, and it's negative. And there we go. So it's kind of like taking a number. Basically, I divided the 12 by 2, and then I took that 2 and I multiplied it by the other term. Or another way to think about it is kind of like what we did above, where we break up that number and kind of apply the 2 to the other one. I feel like I'm stumbling over the way I'm saying that. All right, here, let's try another one. Let's see. Let's do, how about negative 14 times 4? Not so easy to do on our head. However, we could think of the 14 as 7 and 2. And I could kind of apply that 2 to the 4. So I would have 7 times 8, right? Because 4 times 2 is 8. And well, that's easy. That's negative 56. We should know that one. So that is kind of how it works. You kind of pull one number off and apply it to the other number. Okay, let's try one. Let's try, let's do 28, negative 28, oops, times negative 25. Okay, so of the two numbers, the one that disturbs me the most is the 28. I'm just not as comfortable with 28. Now, there's a couple ways I could break that number up. When I see 28, my immediate thought is 4 and 7. Sorry, the computer's going slow. There we go. And I could apply 4 to 25 because I think that is quarters. 4 quarters is $1. So what I have is negative 7 times negative 100, which is 700. So that's one way to do it. Let me show you another way. Another way to have done it is, like, let's say you looked at the 28 and you were like, okay, well, that's 2 times 14. So what if I thought of it like that? And then took and applied the 2 over here instead. So let's see, that's negative 14 times, okay, that'd be 50. I still can't do that in my head, so I might do it again. I might break 14 up one more time. 14 is 7 and 2, and then apply 2 again to that number, which would give me the 7 times 100. Oops, negative 100. And there we go. Same result. But the idea is sometimes there's multiple ways to do it. And you, as long as you're showing me the work and I can follow it, then that's fine. You're able to take a different route than maybe what I would have taken. Okay, so that's equal products. Equal quotients works a little differently. So let me go ahead and write that down. Equal quotients. So with quotients, we have some tricks up our sleeve, namely that and I'll just kind of write this off to the side. You don't have to write this. We have this idea that we probably remember from like fractions, and we will be talking about fractions. Like, let's say we have the fraction 15 over 20. You might remember that we can divide top and bottom by a common number to reduce it. And this ends up being 3 over 4. We can use that trick if we happen to be working with a division, because 15 over 20 is just the division of 15 divided by 20. So we can do this trick where we multiply and divide both numbers by the same thing. So that's the trick we're going to use for equal quotients. We will multiply, oops, there's an L, multiply, sorry, computer's lagging there, or divide both numbers by a constant. All right, let's look at an example. Let's say we have negative 144 divided by 18. Okay, that's hard to do right off the top of my head. But I happen to notice that both of these numbers are divisible by 2. So I'm going to divide them both by 2, which means, okay, 144 when divided by 2, 2 into 14 is 7. Oops, sorry, I forgot the negative. 7. And then 2 into 4 is 2, so negative 72. And then 2 into 18 is 9. And okay, I actually happen to know 72 divided by 9, that comes out to negative 8. That's just using our multiplication tables that we should hopefully know. And that's how we kind of do the equal quotient method. Now I'm going to do that one I started to write earlier, and we'll actually tackle it this time. Negative 150 divided by negative 6. I think it was positive 6, but I'm going to make it negative because why not? Okay, so let's see. It would probably be wise. Again, I noticed both of them are divisible by 2, so I'll start there. Oops. I don't know why I switched to blue, but I really want to work with red. Okay, so 150 divisible by 2, that's negative 75. 6 divisible by 2 is negative 3. And I think quarters, right? 75 cents divided by 3, that comes out to 25. And there's that way of doing it. Let me see if I can find an example where they're both multiplied. Hold on. Ooh, okay, here, I got one. Let's try this. Let's say I want to do 1,700 divided by 50. We'll just do both positive numbers. Okay. Here's an example where it might actually be wise to multiply by something. I'm going to multiply by 2. The reason is 50 times 2 is 100, and I like that better. So let's see. That's going to give me 3,400, and this is going to give me 100. Okay, well, that's just going to be 34. So we're kind of using something common like that to divide both terms and try to make our life a little bit easier. It's possible, by the way, for the second one, that we, instead of dividing, sorry, this example right here, instead of dividing both the numbers by 2, we could have divided both the numbers by 3. Let me just show you that briefly. In case that's how you saw it. You were like, oh, I would have divided them both by 3. Hey, that would work. So let's just do that. If I divided both numbers by 3, in fact, that might even work a little bit easier for some. That's just going to be negative 50 divided negative 2, which is negative 25. I'm sorry, positive 25, because negative divided by negative is a positive. So there we go. It could have worked that way too. Just so you know, there's multiple ways you can do it. It's the idea though, is it's supposed to be something you can figure out in your head. And that's kind of the game here. And there we go. There's mental calculations.